Alright, so we ended class with this integral, and this is a doozy of an integral. So somebody had recommended that we turn this all into secants. I think it was Caitlin, and that's absolutely correct. To solve this, you need to turn this into secant squared u minus 1 times secant cubed u du. So you're looking at pi over 4 integral of x equals negative 1 to x equals 1 of secant to the 5th u minus secant cubed u du. Now, this is two separate integrals that in and of themselves are both fairly long integrals. So the first one is x equals negative 1 to x equals 1 of secant to the 5th u, and then du minus the integral from x equals negative 1. Let's make that a little cleaner. X equals negative 1 to 1 of secant cubed u du. Now, this secant cubed integral is actually proven in your book how to find it, and they use that as a formula from then on out. So they say the integral of secant cubed u du is equal to 1/2 of secant u tangent u plus the ln of secant u plus tangent u plus c. So they just derive that formula. That is on page 449 of our Talman textbook. And I would just use that formula to solve it. Now for the other piece, we're going to need some more room to do. So I'm going to open up another slide here, blank page. So the integral of secant to the 5th u du, we would need to write as the integral of secant cubed u secant squared u du. And again, we're going to pick integration by parts. So our u is going to be secant cubed u. Our dv is going to be secant squared u du. Actually, u and v are bad variables to use because we already have those. I can use v, but let's use w and v. So dw is going to be 3 secant squared u times secant u tangent u. So that's actually 3 secant squared u, or sorry, cubed u tangent u. That's dw. And then v is going to be tangent u. So this is going to be u times v, or sorry, w times v. So that's going to be tangent u secant cubed u minus the integral of v dw. So 3 secant cubed u tangent u du, tangent squared. So if you're still following, you might notice right here that we're starting to loop. So we have a looping process going on here because this was part of the original integral that we had. So we should get something that looks sort of like this, and if you'll notice, you have the pi over 4 with this piece, and this piece is opposite, so you could end up adding that over and get a pi amount of those. And then you would keep going and trying to solve for the secant cubed term, and then you would plug in and evaluate after you went back in terms of x what you would have for this integral. But I will say this turned out to be way overcomplicated for what we really want to do and show. So sorry that I had picked a problem that ended up having a very, very ugly integral, but it's good to see these trig substitutions again.